Hi and welcome back. I am a hacker and it's really nice to have you on board. In this video, I will be going over UDP. In the previous video, we did understood UDP theoretically, like we understood what kind of protocol it is, what kind of header it uses, and stuff like that, just theoretically. But in this video, we'll just go over the UDP like practically, analyzing it in Wireshark. Just to get things started, UDP is a protocol in the TCP IP suite of protocols, and IP is in the network layer. That's the network layer that of in the OSI 7 layer reference model. IP in the network layer carries the IP address that has the information about how to get packets to its destination. The transport layer sits on top of the network layer, and that carries information about how to differentiate between network application. That information about how those network application gets differentiated is in the form of ports. So the transport layer has ports and the network layer has, in this case, an IP address. UDP is a transport layer protocol, and UDP stands for User Datagram Protocol, which we discussed in previous video in very detail. It's often called connectionless or sometimes unreliable. Now, unreliable doesn't mean that you cannot trust it at all. It doesn't mean that it's not worth anything. It just means that there is nothing in this protocol that says that it's going to guarantee that the datagram that you have sent are going to get there. So datagrams are sent out on the network with nothing at all as a form of safety net. If you wanted to use UDP and you needed that type of safety net, you would have to write that into your application. So that makes UDP a fast protocol. That's one of the reasons why it's good. It's also one of the reasons why it's unreliable. In order to get that speed, you don't have all of those error checking and validation that messages are really getting there. So because it's fast, it's good for things like games and for real-time voice and video. Anything where speed is important, you would use UDP right there. So right over here, I have got a packet capture that I took, and I'm going to narrow down my focus here in Wireshark by applying a filter that says UDP. And once I press enter, you would just see a list consisting of just UDP requests. So I'm just going to take a look at one of these packets, and once I click on it, I will just select one packet, and that is a packet that's originated from my system, and it is a UDP packet. So I will ignore these lower level layers which says frame, Ethernet and Internet protocol, and I will straight away come towards the user datagram protocol. Now once I click on this arrow, it will just expand this user datagram protocol, and once I expand it, still I don't see awful lot of information. I just see the source port, the destination port, the length, and the checksum. The reason why I just see source port, destination port, and the length, and the checksum is because UDP doesn't come with an awful lot of headers because it doesn't need any. The only thing it needs is to tell you how to get to the application on the receiving host. And that's where the destination port is. Once the message gets to the destination, all the destination needs to know is how to communicate back to the originator, and that would be through the use of source port. A return message would convert the source port to a destination port and send it back to the originator port in order to communicate with the originator. So we have a source port and destination port for doing that, and we have the length for minimal amount of checking to make sure that if the packet that you have received is different from the length that's specified in the UDP headers. If that's different, then there may have been some problem or something may have been wrong. So you may want to discard the message. The checksum also makes sure that nothing in the middle was tampered with, although if there is some sort of man in the middle attack or something other like that, the checksum is pretty easy to manufacture after you have altered the packet. So you can see here in the message that there are a number of UDP packets. Some of them just say UDP. The one I'm looking at here happens to be form of a Skype application talking to Skype server. And we have also got DNS, and now DNS also needs some fast response time, because you don't want to spend a lot of time looking up information about servers that you are going to before you just go to them. So DNS server throw out their queries on the wire using UDP, hoping to get fast response. They don't want to spend a lot of time setting up connections and doing all of the negotiating that comes with a protocol like TCP, for example. So you see here that the DNS is using UDP, and what we have got here is another UDP source port. If I expand this user datagram, so what you can see right over here is source port, destination port, and what we also have is DNS port or domain fork, which is 53. Right over here you can see. Like if you look at different UDP, if you look other UDP packets, you would just find the destination port different. But if you look up on the DNS, you will always find the destination port as 53 at the bottom of this Wireshark. Now if I expand the DNS and I come over to the query, if you open up the query section down below, we are going to look for a type A record, and you can see right over here we have the type A record, which just means is I need an IP address or just the address of the host name pipe.skype.com. So that's some information about the user datagram protocol. You would say that why do we need to know about this domain name systems or DNS? Why do I need to know about these queries, and why do I need to know about these different layers that comes with Wireshark? And what is the reason why we are looking at the UDP in Wireshark? Well, it's really important to understand these things, because performing a network scan or hacking anything or doing a recon on a target, you must need these things. Like if you don't know these things and you are performing a network scan, you will get this data, but you won't be able to understand what's happening, where the request is going, where the request is coming from, and how to analyze a network search and stuff like that. In hacking, these things are really important to understand first, then you would be able to do some dirty stuff with hacking or perform some stuff for a client or get into bug bounties and stuff like that. So understanding these things for a beginner is really important. Then you can get to some dirty stuff. So this is pretty much it for the UDP in Wireshark. In the next video, we'll look at how to analyze TCP packets. I hope it's pretty clear. But up till now, this is pretty much clear because I tried to make things as simple as I could, and I made it, I think so. If not, leave a comment down below how I can make my video more helpful and how I can give you more info about my videos and stuff like that. So this is pretty much it for this video. I hope you did learn something. Till next time, enjoy hacking, stay cheeky breeky, and peace out.